Welcome back. So in the previous video, we learned how to determine the Young's modulus from our stress strain curve. Now that we figured out the elastic region of our curve, the next step is to find out the yield strength. Now unlike Young's modulus, the yield strength is not straightforward to determine. If you look at a realistic stress strain data, the transition from elastic region to plastic region is not always clear. In some materials, you might see a sharp yield point, but in many cases, the curve just gradually deviates from linearity. So the question is, how do we determine where the yielding begins? That's where standards come in. So in this video, I'm going to share the details of two different standards that people typically use to find out the yield strength using a stress strain curve. The first one is the 0.2% offset method. This is the most widely used approach. Here we take the elastic modulus that we calculated earlier, and then we draw a line parallel to the elastic region of the curve and shift it by a strain of 0.002, and hence the name 0.2% offset method. The point where this linear line intersects the curve gives us the yield strength. Now, you should note that the accuracy of this depends on how accurately we determine the starting point of the curve as well as the Young's modulus of the material. The second method is a simpler one, and it's called as the 0.5% strain method. Now, instead of constructing a parallel line to the elastic region, in this method, we simply go to the 0.005 strain value on the x-axis, and we draw a vertical line, and wherever it intersects the curve gives us the 0.5% yield strength. This is a quicker and easier method and can be used and is used in cases where the transition from the elastic region to plastic region is not obvious. So now you have seen and know how to determine the yield strength of material from the stress strain curve using different methods, and you can always use the Python code that I have shown you. So as always, let me know if you have any questions or need the code, or if there's any suggestion to modify it. And in the next video, we'll continue along and try and figure out the tensile strength from a stress strain data. Okay, so that's it for this video, and I'll see you guys in the next one.